space and the design of space and the qualities of space dramatically affects people's experience.
This is one of those buildings where what you see is a manifestation of the ego of the architect.
I have like an absolutely massive amount of respect for the engineering that goes into these buildings.
There are times sometimes when you can build up that level of confidence and you can build up a level of trust, but you need to start from the basis that everyone is talking the same language and you're all trying to achieve the same thing.
One of the things that is extremely complex when you come to this type of designs is having a balance between the competency of all parties.
We literally do not need another building. We can refurbish, use what we have and repurpose it.
Those constraints can also be seen as drivers. Those shrinking budgets, those additional requirements, that's when innovation, that's when the fun starts as an engineer.
Because every minute they're there, it's affecting their life. Love that.
Okay, so hello everyone. It is my pleasure to welcome you all today on behalf of the Society of Engineering and Architectural Design to our first ever SEAD Engineers panel. The topic for today's event is holistic engineering and sustainable development. And we will be looking at how engineers can achieve integrated design considering a variety of disciplines and project aspects in unison, whilst aiming to deliver projects sustainably and responsibly. As most of you shall know, I'm Michał Kierat, a co-founder of the Society and an academic rep for the MNGAD program, and I will be chairing today's panel. If it's your first time joining a SEAD event, we invite you to become a member of our society through the UCL Students' Union with our free remote memberships, which will be valid for the entire academic year. And please do follow our social medias to hear about our latest news and events. So our schedule today consists of 3 main segments. After meeting all the panelists, we will begin with a warm-up quiz and some discussions. We will look at a few famous examples of controversial projects and judge if they are a success or a failure. Our panelists will then each present to us a project which either they were a part of or is of particular interest in relation to our topic. And then finally, we will open the floor to any questions and we will have some further discussions on the projects and today's theme. So we are delighted to be joined today by 4 panelists, Laura Hannigan, Anderson Inge, Professor Jose Torrero, and Michael Widrow, who all accepted our invitation, and we are very generously supporting this event and our society with their time and input. And I thank them very much for their attendance and look forward to the rich discussions we will hopefully have. So our panelists come from a variety of backgrounds within the built environment, and I welcome them to briefly introduce themselves. So Laura.
Hi everyone, my name is Laura, you've gathered, and also perhaps that I'm a structural engineer. So I studied in Dublin and in Cambridge and in structural engineering with architecture and interdisciplinary design. And I've worked in Thornton Thomas Study in New York and London and AKT2 in London, if you know them. And now I run my own practice with some great friends as a structural engineering consultancy as well.
Thank you. Anderson?
Hello. I'll wait until Laura's picture changes there so people don't think I'm Laura, but thank you. I grew up on a farm north of Dallas, Texas, and I've been happily stuck in London for nearly 32 years. I see myself these days as an architect and a structural designer and a sculptor. Originally studied at the University of Texas in Austin, then at the Architectural Association here, then back in Austin, and then at MIT. And the only famous architectural practice I've worked for is Cambridge 7 Associates in Cambridge, Massachusetts, located midway between Harvard and MIT there. They're famous for doing lots of aquariums, some of which I worked on. Michael sent us some prodding questions. How did you get there? I got there because I sat next to Serge Shamayev on an airplane. and his son runs Cambridge 7 Associates. And then I later worked on a number of Dallas clients for Cambridge 7 via Serge Shemaev. And let's see, special areas of interest: drawing, building, and reading screenplays. Thank you.
Thanks, Anderson. Jose?
Okay. Here I am. So I'm Jose Torrero. I'm originally from Peru, and I'm actually a mechanical engineer by education. And I started my career doing one of the most extraordinary integrated designs, which was the International Space Station. And little by little, I landed onto the Earth and devoted my entire professional life to fire safety. And I've worked extensively with architects and structural engineers, all sorts of engineers in different matters associated to the design of all forms of infrastructure.
Thanks, Jose. And finally, Michael.
Hi there, I'm Michael. I'm a fire engineer like Jose and a lecturer in engineering education. I originally studied civil engineering, civil and environmental engineering at University of Edinburgh, and I also took classes at University of Queensland in Australia and Princeton in the States. I've previously worked at Foster & Partners, and I got there in a similar way to Anderson through a contact. In my case, it was Jose. So I came in one day during my PhD and I told Jose that engineering needed to be incorporated into the design of buildings, and therefore I needed to get into an architecture practice. And Jose put me in touch with someone in F&P, and together we created the role. And my final thing, my special area of interest is in invisible architecture, where the user loves being in an environment that I've created, but has no idea why.
Thank you, Michael. So thank you very much to all our panelists, and we can now begin with our warm-up quiz. And as I mentioned, we will look at a few case studies that may or may not be known to our audience. And I will briefly present a few key facts about each project. In the meantime, we invite the audience to interact with us through the on-screen polls that will appear. And we ask them to vote what they think of the project, if it's a success or failure. And then we will turn to our panelists to hear what they have to think. So let's begin with our very first project, which is 20 Fenchurch Street in London. And I am launching the poll for the audience. Do you vote and let us know what you think? So this project is otherwise known as the walkie-talkie or the skyscraper, and it is famous for its solar glare problem. And it's the building's concave shape reflected intense rays of sunlight and was reported to be causing super high temperatures on street level, ranging all the way up to 100 degrees Celsius, as well as damaging local properties such as melting bodyworks of the cars parked outside on the street. And the glass has since been covered with a non-reflective film. I remind the audience to vote about what they think about the project, and I turn now to the panelists and ask for their view. So Laura, do you think this is a holistic design project?
It might be holistic design, but holistic design can still have bad outcomes. My difficulty with it is its context to its surroundings. When you walk around that area of London, and there's very, beautiful, small, intricate, unique, historic buildings, and I think that's the biggest failure on my part, is its placing within the context.
Right. So as we can see, 85% of viewers agreed, are saying that it's a failure. So how can we ensure that mistakes like this do not happen in projects? Would anyone like to take that up?
I may be the only person that thought it was a success, so I'll take up. Projects do have failures. I think this project is a huge achievement, which is different from a success. it is a huge achievement to create that thing. And all projects of scale have mistakes. Some of them you never see. This one we clearly did. It made international press. But nonetheless, I think it's important not to miss the achievement in this building. One of the biggest achievements in the building, not only structurally, is its sense of gesture on the skyline. Thank you.
Thanks, Anderson. So just to add to this topic, even though this mistake did happen, the architect actually did specify in the original plans that there was supposed to be a horizontal louver system on the south side to prevent this problem. But for whatever reason, it got lost at a planning stage. So would this fact, if you knew it or not, does that change any of your opinions about the project?
Could I just get Jose to open his mouth, because I can see he's biting his tongue to say anything. So please, Jose, just let it go.
I know that's I just have a very simple opinion about that building. I mean, this is one of those buildings where what you see is a manifestation of the ego of the architect that basically supersedes everything else. And yes, as Anderson said, it has a lot of very interesting achievements within the building, but as an overall building, it really crashes with so many things, either in context or in performance, that I think overall the point gets missed. And so yeah, no, I have a very strong negative opinion with this building, but I'll just leave it there.
Okay. Michael, do you want to add anything to that?
I have a similar opinion to Jose. I think there were several really strong drivers for building, in particular net. So what they did essentially was they were able to create more floor area on a footprint of ground than they would otherwise be able to do with a straight building. If hitting a fat building, they're overhanging the street space, and they're increasing the net lettable area. I think the net lettable area is something like triple the size of the Gherkin. It's a significant larger floor plate. So it's a project that, although it's disguised under the ego, it really is finance driven, as absolutely driven by maximizing net lettable area. So yeah, I think the wrong design drivers took precedent in this case.
Yeah, and I think one thing that is important to note is that actually Rafael Vignoli is very well known for being the leading architect when it comes to maximizing surface area.
Okay, and when it comes to conflicts of interest between holistic design and, for example, clients' expectations to what they want to achieve, for example, in terms of floor area, which should take precedent? Which should be the more important driver, do you think?
I'm not sure one can be more important necessarily than the other. It's like that you have to work really hard to marry up both as best as you possibly can, even though that might be a bit of a hopefully not a non-answer. But I think when it comes to that, the biggest thing is communication and educating a client about the pros and cons and the implications of what they're doing at every point and every stage. So if you end up with like a very inefficient structure, communicating that and telling them, listen, the embodied carbon of this is, the equivalent of the deforesting the Amazon forest. But if you went like this and you have a smaller net lettable area, but it's a much more appropriate like design form, if they still decide to go with paying for having like a massive carbon footprint, there's not that much you can do about that. From your own conscience point of view, you may need to make decisions about that if you are able or willing to still work with that client or not. But all you can do is educate them as best as possible.
Sure. Okay,
Anderson's got
Anderson,
now.
do you want to say something?
I think it's important to be realistic that often drivers are client-driven. Designers often shape those drivers and influence them, but often drivers are client-determined. So, and also, you know, there's big trends going on. It's entirely possible we'll never see buildings like this beginning again. These things have a 15-year lead time between COVID and environmental crises and a number of trends. It's possible these will end themselves.
Thanks, Anderson. We'll move on to our next case study now, which is the Louvre Museum. And I am launching another poll now for our audience. So as you can see, it's a heritage structure which served as a royal palace since the 14th century and as a museum since 1793. In the 1980s, the museum was subject to a major expansion, which involved the construction of a vast underground complex within the site. And the prominent glass and steel pyramid decorates the ground level entrance. And it was designed by the late Chinese, sorry, I think there's an echo. It was designed by the late Chinese architect Union UCL. And the design was met with quite heavy criticism, mainly for the inconsistent architectural styles, amongst other things. So the audience is telling us that they believe it was a success. And panelists, do you see this project as a success or failure?
Well, I may have been the only one that said it was a failure.
I'll trust the architect to go just rub everyone, just go against the grain regardless.
Well, I'm sorry, but you know, in a way, it's a beautiful thing, and the concrete work in this building and Pei's film about the creation of this concrete work is an unbelievable achievement to get concrete put in place that looks as beautiful as that concrete does. But it's not the glass pyramid. The glass pyramid, I just think, is a tech fest. And I think it has the problem of making the facades of the Louvre, the heritage building, look like a Disney facade. The contrast is just too tough.
Okay. But if we're taking the whole project of further developing the Louvre, what do you think that what role does heritage play in terms of delivering sustainable projects?
Well, your question's a big one, Michal, because you know this project tripled the size of the Louvre's exhibition space, and it connected the Louvre. The program of this project is genius, and many museums have followed exactly the same program. The museum in the Hirshhorn in Washington, D.C., and just all the way around the globe. So one's got to probably pick apart, you know, the aesthetic achievement, the programmatic achievement, the structural achievement. Programmatically, it's genius.
Does anyone else have something to add?
Yeah, I think that, I mean, I have to say I completely disagree with Anderson in regards to the pyramid. I think that for me, what the pyramid adds is what was missing from that space. I mean, people forget that you had the Tuileries Palace in front, and that courtyard had an actual use, and it was never intended to be an open esplanade as the way it was before the pyramid. So the pyramid comes to fill a number of gaps that already existed historically. So it does have some historical faithfulness, you know, to the context of that esplanade. And from my perspective, it enhances the historical value of the building. It actually provides sort of this other element that for me is so important in integrated design, that effectively whatever you're putting in there that is new is adding and complementing what already exists in there. So from my perspective is intrusiveness, the contrast. Without that contrast, you will not have the emphasis that you have in the historical elements. So I think that the way I look at this space is I imagine that is planned out without the pyramids, and it will be pretty boring.
I think the key with that as well is it's in terms of the conflict and the contrast is that it is separated from the element as well, so you can read them independently and distinct. And I think sometimes when it goes really difficultly horribly wrong is when something is really forced into a heritage building, whether it's on top or right in the middle of it, or half of it's ripped apart. And I think the reason why this one is successful on some of the points that were mentioned is because it has that separation and can be read, the pyramid itself, separately from the heritage structure around as well.
I think in addition to being physically separate, I think as well being is separate in terms of the style. I think some of the biggest mistakes I've seen in heritage buildings is where people have tried to copy, and I really don't like modern copies of old structures. And if you are going to do anything with a building as beautiful as the original Louvre Palace, then I think the only possible option in modern times is to move with the times and to create modern architecture as a perfect sort of symbiotic relationship with it, rather than trying to make somehow a crap facsimile of it.
I think what Eric Perry did for the St. Martin's in the Field just off of Trafalgar Square on the east side is a good example of a halfway ground where the language of the new architecture is clearly a weave of materials and forms that are brought from the old structure and new forms from the present time and programmatic. So I'll just suggest that one building, Eric Perry's there, St. Martin's in the Field, as something that is not as complementary or as divergent as the pyramid to these facades.
Thanks, Anderson. And very quickly, we'll move on to one more example, which is the Jeddah Tower in Saudi Arabia. And it is set to take the crown away from the Burj Khalifa as the world's tallest tower, standing over 1 kilometer tall. Designed by Adrian Smith, originally from SOM, and with structural design from Thornton Tomasetti. The building will consist of a variety of uses, including offices, hotels, and a large amount of residential floors, including penthouses at the very highest floors. Is this a success or failure?
Can you just remind me, when we say success or failure, it's from a holistic design point of view?
Yes, and sustainability.
Yeah, okay.
Yeah.
Thanks.
Mikhail, I have to admit, I was typing at the moment. I just hit the wrong button. I sent it in a success. I meant failure.
Okay. Noted. So, Laura, would you like to start, since you worked with Thornton Tomasetti before, right?
Yeah, I did. Yeah, this was ongoing in the office when I was there. It was at like the very beginnings, and you know, it's interesting because I think maybe even now the actual final height is still under wraps because they don't want somebody to come along and rapidly throw something up that's much quicker. I have seen a lot of talks and heard speaking of the Burj Khalifa from, you know, Bill Baker, the one that's currently the tallest. And I have like an absolutely massive amount of respect for the engineering that goes into these buildings. And it is a massive, you know what I mean, unprecedented feat of engineering on how to, you know, create something like this. I think that there only needs to be maybe one in the world, and that's enough. And I think the difficulties with it are from a massive sustainability point of view. Nothing really needs to be that tall other than to say that it is the tallest. From floor plate construction materials the majority of it is going to end up being like a core with very little floor plate once you start to get around the bottom. And so ultimately, I think if we're going with this black and white success failure, I did hit failure, even though it is a great feat of engineering.
So you actually answered the two questions I was going to ask, which is, do we really need to build this tool? And if you think it's a sustainable project. So you answered that perfectly. Before I let the other panelists answer, I just wanted to highlight the amount of materials that were used on the project. So the concrete foundations themselves, a 5-meter deep concrete pad, over 7,500 meter square area. There's 270 board piles over 100 meters in depth. The total building weighs almost 1 million tons, with 500,000 meters cubed of concrete and 80,000 tons of steel. So would anyone like to express how they feel about such a quantity of resources being used to build something that may or may not be fully inhabited in the future?
A couple of years ago, I went into a meeting where the client was wanting to remove a concrete floor from a heritage building, and I asked them not to remove it and to try to reuse the existing slab. And by way of trying to persuade them to keep the concrete slab, I told them what the volume of CO2 that would be emitted into the atmosphere when they replaced that slab was. They couldn't have cared less. You could have heard a pin drop. I was just about laughed out of that meeting. But you could do the same calculation with 500,000 cubic meters of concrete. It's terrifying.
Yeah, and I actually attended a lecture from the lead engineer from Fortin Tomasetti about this. And I asked the question, did anyone actually calculate the embodied carbon that the project would entail? And he replied that, not to his knowledge, anyone had done that in the office.
I think previously there's been an attitude maybe as well where you would see the headlines of projects. I mean, in a general sense, I mean, even across like London or different cities, and it would have, 80,000 tons of steel, as a headline of like, this is amazing, we've done this, or we've just poured like the largest concrete raft in London. It's the biggest pour, and it would be a boast. They'd be super proud of it. And I think that there is a shift change, and hopefully there is, where people realize that now they see the headline and they're like, wait, that's not a good thing.
Absolutely.
I think this, I completely agree with what Laura said about, it seems like this is just a boast. This is the equivalent, the structural engineering equivalent of what the walkie-talkie was to the architect. It's an ego thing. This is clearly just to hold the record. And so you have a structural engineering feat, which I completely agree with, is very impressive. But beyond that, really, there's no justification for this. In Manhattan, the reason why you go for tall and super tall, or any densely populated area, Hong Kong, Shanghai, the reason is because you lack space. And here, they're building it in the middle of the desert. There is absolutely no justification in the context to build this tall. Plus the shape of it, if you take a triangular building, at some point you need a core that brings you up via the lifts and the staircases. And that core takes up the majority of the floor plate. And once you reach a certain point, it takes up the entirety of the floor plate. Therefore, the top of a triangular building is totally unusable. So really, probably the top you can see in the image, second from right, the top third is totally unusable space. It's just the structural engineer's ego put on top of the building. I think from that perspective, the justification from a sustainability perspective, well, for me, it's not justifiable in any way from a sustainability perspective. It's pure structural engineer's ego, this project.
Jose, do you want to add anything before we proceed?
No, not much. I think that everybody has expressed themselves, and I'm only going to throw more petrol into the fire if I keep talking.
Nice fire analogy. Okay, thank you very much to our panelists. That concludes our warm-up, which I hope everyone enjoyed. It's now time to hear from each of our panelists in a bit more detail about a project they wish to share with us. So I remind the panelists we have approximately 6-7 minutes to present our segments, and then we'll we'll proceed to some questions. So I think we'll begin with Laura, if you want to share your screen.
Sure. We've slated everything so much now, you know, there'll probably be some slating of this as well. So can everybody see that?
Yep, we can see the screen.
So I think I'm going to set a timer because I will do 6, 7, 8 minutes. The interesting, in terms of talking about a project, I think, you know, you'd mentioned about talking about a project that we're proud of and or like is holistic engineering or design. And it was super difficult in terms of thinking of one that I was proud of, because it is a totally cliche to say almost every project you can have like a bit of pride in it for a different reason. So that might be because of, you know, it was my first project, very first project, which is, you know, the stadium, or the first one that I had full kind of project lead on, which is like, you know, a CLT kind of small domestic house. And so I ended up just going at one which had some principles of engineering, which I thought were interesting, but you will all be the judge of that. And it was also one that you can hopefully walk down to site or walk past and see. So it is the headquarters of Google in King's Cross, which we were hoping to go on a site visit and see, which we couldn't do, unfortunately, this year because that whole virus kicked off. The building, I think, can probably fall into one of those success or failure slides that we could debate about. But from an engineering point of view, what is interesting about it, and hopefully what you'll find interesting as you walk past it, because you wouldn't be able to tell a lot of this just from the outside, is some of the way it's structured and some of the engineering that went into it. So it's located on a plot in King's Cross. So King's Cross station is down here, if you can see my cursor, and then there's a network rail line which runs straight beside it. And the network rail lines and the train lines form a massive constraint in this project, because putting any sort of foundations near them would have been a problem. So this is you know, just a section through the site. There's like central cores for stability, and then it's made up of kind of these 2D steel plane frames which connect through to the cores through the floor plates. And the system, in order to avoid any foundations near the railway line, some of you will have seen this before because I showed you it before, but the perimeter of the building is hung from a truss at roof level, and the interior side along King's Boulevard is also hung to form this like balanced cantilever. That meant that the foundations near here, right, you wouldn't need foundations right here, right by the railway line, which would have caused some problems. And this kind of upper truss story level is where all the kind of mechanical equipment goes for serving the floors. It was interesting because the form of the building then lent itself to very interesting client and architectural kind of and servicing ideas. So the kind of elements or the floors are hung from the floors above, which provided theoretically a capacity for expanding the floors out to connect to the perimeter, or, you know, reducing them back where necessary. So if the client wanted to expand out the floors or office space, they could. But it would involve bringing CLT panels in. And the CLT panels are kind of on the bottom flange steel beams with the services running through the floors. And this is kind of, and there's a mixture of like precast and CLT floors hung. So the CLT floors are, which are hung from the precast floors, the CLT being quite lighter. And all of the structure is exposed. So here you can see from the underside, because of the way the services and all the servicing happens in the floor above, you can see all the CLT from below, and that's with these step backs to these hung floors, so these kind of 3-story hangers. With all of the elements and the structure being exposed, it's hard to convey how much we spent. I tried to find my old notebook to find all my sketches, but I couldn't find it. How much time we spent around, sitting with the architect and the contractor at the time, figuring out every single bolt and every single steel detail which was exposed, and in the truss level, coordinating with the mechanical environmental engineers, so that every service ran through the trusses neatly and through the floors. So yeah, this is an example of like the plant room truss at the top with the hangers which drop down the side of the building. We did a lot of work with the facade engineering as well, because as the and the temporary sequencing of the project. Because as the building is loaded, the kind of hung floors would deflect and affect the how the cladding is constructed, and as well how it behaves in the long-term kind of use of the building in the project. And if you walk down by King's Cross, if anybody can escape at any point, you can see the building going up at the moment. And if you do manage to walk past it, you should be able to see, or can try and like pick apart and see how it's working. Here, for example, is one of the hangars. And at the moment it is got temporary props like below and to the side of it, because obviously it's not being hung yet and it needs to be connected up into the truss ultimately. So this is to stop it buckling while it's being like loaded as a column vertically. And then, yeah, you can see the CLT floors landing on the bottom flange of the steel beam. And all of these connections are going to be exposed here as well. And this is an example of where the beam will come out and connect into the hanger to potentially infill the floor at a later date. So I kind of did that really quickly because I'm at 6 minutes, but I think the principles of the building were key to meeting the client's requirements. And without the structure or the work that we did in the floor framing, CLT slabs on the steel beams, the hanging it to avoid the network rail line, to me, so much of it, what I see is, you know, directly influenced by our input at the start and what the building ended up being. And to me, what is the architecture and what is the structure and how the building is serviced is hard to pick apart.
Thanks, Laura. Thanks for wrapping up so quickly. If we can, if the audience has any questions for Laura, please put them in the chat and we'll try to come back to them after all the panelists have presented. If I can ask Anderson now to share his screen.
Thank you. I'm blown away by Laura's project. I was at King's Cross on Saturday meeting a friend for coffee, defying lockdown, but doing it safely distanced, and looking at Laura's building. And just like her final photograph there, I was saying, all of the details were just screaming something really unusual is going on here. And I just found it absolutely fascinating. So wonderful to hear about it. This project I'd like to show you is very different. I'm going to do this slightly by sound bites. Historic mining town, Creede, Colorado, 1891, silver, 3,000 meter elevation above sea level, Rio Grande, Upper Rio Grande River, 42 hectare events and recreation, American style fairground site. Trying to avoid complying with style imperatives, Western Anna, if you will. How do you design in the mindset of a place? In this case, we were trying to find what is the mindset of an early settler inventiveness of materials, perhaps intelligent use of materials, sparing use of materials, willingness to reuse materials. So ball courts, community meeting rooms, swimming pool, continuation of Main Street as spine of the building, orientation looking north to the mountains, across the valley to the rising sun to the east in the right. For the ball courts, the larger spaces, suspending the ceiling, the roof, with repurposed cables from the mine, literally brought out of the mine, stabilizing the roof against flutter with a ballasted sod roof, which is a strategy that is prevalent in this part of the Upper Rio Grande Valley. Use of the system lamella barrel vaults, which I've done out in, built with the students out in Alabama. Structuring these, the mountains of Colorado now are 60% covered with standing dead pine as a result of a beetle infestation. I recently finished a structure from entirely harvested standing dead timber. That was the aspiration for the side of the structure on the right there. It's a balance of tension structure meets compression structure. And we enjoyed a lot of trying to figure, well, what do you do with these different thrusts? And the outward compression thrust from the barrel vault, taken with this horizontal concrete beam that sits on a series of fin-like columns looking across the valley to the east, and what amounts to kind of a series of blade-like columns resisting overturning moment. A lot of morning sun. What can't be seen here, tension structures usually involve somehow getting the tensile force to a relatively tall height. How do you get that down to the ground? What can't be seen quite in that picture, but probably you have to go down to this, is this use of a trellis truss to not only take the loads down, but to help with the buckling that usually one has to deal with by taking a suspension support that high above the ground. I liked Laura's phrase about the principles of engineering. The building gave us an opportunity to use the principles of engineering as we were repurposing existing materials to be drivers in the form. I think that's it. Thanks.
Thanks, Anderson, for that very melodic presentation format.
Thank you. Let's see if I can stop sharing there. Thank you.
Thank you. And now we can move on to Jose.
Do you want to put the email? Oh, there you go.
Yep, there we go.
Okay, so this is a really interesting project that started as a great success of integrated design and ended up as being one of the most profound personal failures I have as an engineer for reasons that are actually quite interesting and many times very reflective of the way in which we develop buildings today. So the original concept behind 25 King Street in Brisbane was to build the tallest timber building, office building in the world at the time. And the developer had made a very large investment on the engineered timber product manufacturing. So they wanted to make this as an exemplar of the optimal design of a building. The site was extremely simple. And so it provided very little constraint to the building. The developer was willing. It was the beginning of a very large development that was, in principle, to provide significant profit. So the developer was willing to overspend in this project just to make sure that it came out right. They appointed one of the leading architects at the time in Australia working on timber buildings, top-notch structural engineers, and you name it. It was basically the dream team, everything that you wanted. And one of the most interesting things is that the biggest constraint for this building was the fire safety of the building. Therefore, the fire safety engineering in many ways was the orchestra director working with all these exceptional players, trying to deliver the ideal building. Now, a lot of things were achieved, and it was actually quite positive in many ways. So, for example, this building has very, very, very high environmental credentials because we managed to eliminate all plasterboard from the building. So every structural element is completely exposed in the building. So fundamentally, you have timber all over the place. And but what ended up happening was one of the things that is extremely complex when you come to this type of designs, which is having a balance between the competency of all parties. So at some point, the project hit a wall, and the wall was the capability of the regulator and the capability of the fire service to actually understand the cases that were being put in front of them to try to deliver the objectives of the building. So one by one, a lot of the key features of the building, for example, a CLT staircase, ended up becoming a concrete core. The potential, we had done a detailed analysis to enable, for example, natural ventilation as a function of having floors that communicated with themselves and allow natural ventilation. So the building was 100% passive from an environmental perspective. And of course, that went away because we were required to introduce compartmentalization between floors. So air was not allowed to move between one floor or another. And like that, one by one, a lot of the wonderful features of the building start falling apart because we had no capacity to convince the authorities of the analysis that we were doing. Now, for timber construction, this has become one of the biggest hurdles, which is the imbalance of competency between the parties, because there's a lot of gaps of knowledge in timber design. And to be able to fill those gaps of knowledge, you have to do incredibly sophisticated analysis. And that incredibly sophisticated analysis is only accessible to a very small number of people. And the trust has not been built yet. So what you get is a conflict between the parties, and then compromises are being made. The risk tolerance of the developer starts dropping because they're seeing the approvals risk as being higher and higher and higher, and they're more and more and more willing to compromise and compromise and compromise. Now, the cherry on top of the cake was when we had finally agreed the building was approved. One of the main occupier of the building, the anchor tenant, decided that for whatever specific reasons, they wanted an aluminum composite cladding rain screen that was actually filled with polyethylene, which, as you all know from the Grenfell Tower, that is not the nice type of material to have, particularly in a timber building. And the authorities were very keen to approve and accept the addition of aluminum composite panels to one side of this building. And that's the moment where I think your ethical responsibility kicks in. And I literally had to hit a scandal and engage with the fire brigades to try to boycott the final changes into the building, so that that this component of the building was actually dropped and the building remained cladded in its original manner. So anyway, so that's a story of holistic integrated design that because of imbalance of competency ended up being a tortuous path towards a very non-integrated and unoptimized form of design.
Thank you, Jose. And finally, Michael Woodrow.
Yes, thank you. So this is the Maggie's Centre in Manchester, designed by Foster and Partners. And I remember the first time that the architect came to me. For those of you who don't know how architecture practices work, Norman was involved initially in swishing his pencil and giving a rough sketch, as you can see in the bottom right here. And then it's passed down to the next level down, which then passes to the next level down. And at some point it gets down to the architects that work with me. And he turned up with a rolled up A0, massive piece of paper, and we unrolled it on the carpet in the middle of the office, and we're sort of sketching all over it, and he's asking me as the fire engineer to help out design this all timber building, completely open plan, he's asking me to help make it fire safe. And so initially I started specifying all the usual things: fire alarm system, exit signs, a second escape staircase, etc. And he looked at me and he said, "You don't know what a Maggie Centre is, do you? Come on, let's get in a taxi." And we literally walked out the office, jumped in a taxi, and we drove to the nearest Maggie Centre, which in our case was the Sterling Award-winning Richard Rogers Maggie Centre in Hammersmith. And that's where I started to learn more about the background, more about the understanding what the building needed to be, what they were trying to create by doing this. So the Maggie Centre is came about after Maggie, the architect who started the charity, was diagnosed with cancer, and she went with her husband, who was a landscape designer, to the hospital. They were diagnosed, and the doctor then said, "You have cancer, and can you please wait outside in the hall? I have my next patient to see." So she spent probably the hardest 10, 15 minutes or an hour of her life sitting on a plastic chair in a completely sterile institutional doctor's ward corridor, sort of letting this soak in completely alone, just with her husband. And so she said, we can do better. We're architects. We can do better than this. So they decided to approach major hospitals, major oncology units, cancer wards, and build this center that you could go to right after you've had that experience. You can go to. It's run by former nurses, people who understand what you're going through. It's run on a voluntary basis. It is a charity, and they approached Frank Gehry initially to help them design a building. And more importantly, not just the building, but as you can see in the image at the top here, the gardens that surround it, because there's a lot of that you don't really realize how much a garden can do until you experience it for yourself. And it's certainly it's got a calming effect. And it was very important to have the gardens as an implicit part of the building design. So the way that I then had to change my perspective, I had to change my drivers. So I had to design the building in such a way that we had no institutional references. No beeping, no cables, no wires, no exit signs, nothing that you wouldn't see in a domestic environment. So the idea was that you had to feel like your best friend's mum's kitchen. So it's something really familiar and really domestic and really warm and inviting, but also not your own home. It's not somewhere you would feel like you want to go to sleep. It's definitely a center, but it's somewhere that's very familiar. So it was really important that we had we got the materials right. Warm brick flooring, and the timber clearly has had a major impact. It needed to expose the structure and see these beautiful timber elements. And Norman did try as much as possible to suppress his ego in this one, because it really is not about him. And from the profile, I haven't included the image, but the way you walk up to this building, you can barely see it. You come in from the left-hand side as you see the building here. And you can barely see the building itself. But of course, Norman had to put his ego in somewhere. These trusses here actually represent part of a plane wing. Norman loves planes. If you look at any Foster building, you'll start to see plane parts everywhere. And that's where these trusses came from. And so the idea was that people would come to this center. The staff were the only people allowed upstairs. They would be able to look down and see the people below without looking like they were hovering over them. They would just see if someone needed a bit of help. And the head of this building actually said to me, it's when they're busy that the building really starts to do the work. And I was wondering what she meant by that. And she said, it's when we're all occupied with other people and you see someone wander in. Maybe it's a man who's not used to asking for help. You'll see them wander in and they just look a bit uncomfortable. They're not sure. They don't really know what to do with themselves. And all of a sudden, you can see the building starts to work. They start to engage with the building. They pull up a seat at the bar. Like, they could pull up a seat at the bar. That's fine. And they start making themselves a cup of tea. And they suddenly, you can see everything just puts them at ease, takes the stress away. And so it was really important for me to understand every part of that concept, to be able to understand this, and now to be able to understand the fire safety and strategy. And now you can see no cables anywhere. The exit signs were turned into simple text in the windows that says to the garden or to the car park. And the result is a beautifully integrated design that's where the main drivers, the most important drivers, have really taken precedent in every case. I think the only part that wasn't integrated, the only part that the architect fundamentally messed up, was he drew the two sections. So note here to everyone, he drew two sections, one for the upstairs and one for the downstairs. He didn't draw a total section of both, which meant that when you walked up the stairs, because he'd drawn the stairs going up, and then he hadn't drawn any stairs in the top landing. When you walked up, you smacked your head on the wooden beam on the roof, because it came to about here, right across your face. You weren't banging your head, you're banging your chin, and so we had to actually bring in some carpenters and reroute the staircase in situ after the building had been designed. So make sure you take your sections properly. But in this case, going onto Jose's point, just for one more minute, in this case, we actually had firefighters who did say, like Jose said, that the regulators that were they were unsure about this. They said that this was not compliant in multiple different ways, and they were not going to give us approval for it. So we invited them to site. We took them through every part of the building. We showed them exactly why this is not compliant. We know it's not compliant, but this is why it's fire safe. This is not compliant. We know it's not compliant, but this is why it's fire safe. And they approved it on the spot. So I think there are times sometimes when you can build up that level of confidence and you can build up that level of trust, but you need to start from the basis that everyone is talking the same language, and you're all trying to achieve the same thing, which in this case was fire safety.
Thank you, Michael, and thank you everyone for your very concise presentations. And we apologize that you had to rush so quickly, but I think we managed to capture a lot of information through that. We have 2 minutes left, so I will quickly open up the floor for any questions the audience may have. Please write them in the chat. And in the meantime, I'll ask our panelists, what is the one tip that you would give for engineers who want to do integrated design and have that as their main objective?
You want it in the chat or spoken?
I'm asking the panelists now.
So, yeah, I'd say learn to draw actively with your collaborators.
Anyone else?
I would agree with Anderson. I think that that drawing is a mechanism of communication, and I think one of the biggest problems when you're dealing with different engineering disciplines, architects, and so forth, is fundamentally being able to communicate in a manner that is accessible to everybody. So sometimes a proper sketch or a drawing is really something that goes very far in that direction.
I think in addition, it's not just about communicating with others, it's also about developing your own ideas, developing the ideas you have in your own head. I think one of the main things that has helped me with, for example, the project that we just saw, was being able to visualize the design long before it ever manifests itself in reality. You have to be able to visualize it. So if you can't visualize it, you need to figure out a way of visualizing it, whether that's drawing or building a model or creating a 3D model, whatever it is that that you have to do to be able to visualize that design. You can't communicate to anyone unless you yourself are fully understanding of what you fully understand what it is you're designing.
Okay, I think Laura might have left us.
I think she just dropped off. I think looks like her screen had frozen.
So if there's no questions in the chat, I think we're ready.
I have one. I'm typing.
Okay, you want to ask it?
My oh, by the way, my signal went.
Oh.
I'm back.
If nobody's asking, I'll just talk. Is that okay?
As long as it's short, Peter.
Okay. Basically, I would like to ask the panel about the implications of an increasingly tight sort of carbon budget that you can work with. Is this like does this inspire maybe thoughts of actually not constructing and stuff like that, and like where does construction go after that phase?
I think
you
you're
know what I
asking
mean?
What are the implications of a shrinking budget on a project? Peter? I hope I'm interpreting your question correctly.
Oh, sorry, I was muted for some reason, but like I was wondering whether or not it's important to decide whether or not we should build something in the first place, and maybe have a different metric of like measuring things in policy that's not economics, if you know what I mean.
Well, yeah, embodied carbon is a good measure as well, and I think the question about whether you should build at all is a very relevant and current one. And there's some in the industry who, have come out and said that we just shouldn't build anymore. Basically, that there's like enough existing stock in certain parts of the world, in certain densification in the city, that we literally do not need another building, that we can refurbish, use what we have and repurpose it. And I think that is a very valid question and point. And sometimes when you see buildings being knocked down and be rebuilt, it's particularly a valid point and question as well.
I think as well, you can see it either as a constraint, that a small budget, or forcing you to do it, achieve a certain BREEAM or LEED rating, or achieve a certain amount of embodied carbon. But as Jose's presentation last year to the now 4th years, those constraints can also be seen as drivers. Those shrinking budgets, those additional requirements, those additional sort of performance criteria that you need to hit. That's when innovation. That's when the fun starts as an engineer. That's when you really start to get innovative and start creating some really interesting designs. If you're forced to start with a certain constraint, that becomes your driver for doing something really impressive and really unique.
Yep.
Thanks, Peter, for your question. And I think that concludes our event. Once again, many thanks to Laura, Anderson, Jose.
The question of should you... Sorry, go ahead.
Sorry, you wanted to answer more?
Yeah, I went to first time a client met the builder that we had recommended, and the builder completely, for the first hour, kept haranguing the client, going, "Why do you want to build this thing? What are you doing? This is going to cost you a lot of money. You're going to be living on a noisy site." And he was relentlessly trying to get rid of the job. And the client says, "I want it." And then the project worked beautifully. She knew what she was up against. And so there's different aspects of it: environmental, the pain of construction, the uncertainty of construction, the budget of construction. All of it is arduous. But, space and the design of space and the qualities of space dramatically affects people's experience. And if you've ever had when you ever have somebody ring you up and say, "I love living in your building," it's a fantastic feeling, because every minute they're there, it's affecting their life.
All right, thank you,
Yeah, okay.
Anderson. Okay, so thanks again, panelists. Thank you very much for your time. Thank you for the audience for participating and interacting with us. We hope you enjoyed the very first SEAD panel, and we hope to be able to apply this format to future events with other disciplines. So do let us know if you have any feedback or suggestions for these future events. Thank you very much, everyone.
Organizers, thank you.
And thank you, Mikhail, for organizing, and Phoebe and everyone else behind the scenes. Thanks very much.
Thank you for the invitation.
Thanks, everybody.
Bye-bye.
Bye-bye.